Hey you guys, welcome back to the channel PHYSICSSIRJEE. I hope you're doing well, and this is the video 3 of a series that I have already started yesterday with regards to the JEE mains final leg preparation, which I'm aiming at the extra syllabus topics. As you could see on the right top of your screen, the topics that are generally less touched upon by the students and mostly feared during the last weeks of their preparation because of lack of practice. But let me tell you, I hope you have gone through the first 2 videos. The kind of questions that they actually ask are kind of repetitive, and once you get a gauge of what is required for attacking these questions, I think this would be very scoring. And since other students are actually not ahead in this kind of a preparation, you would definitely get an edge by attempting these questions, which will therefore propel your rank in the final examination. So we have already finished the JEE 2020 January shift papers in video 1 and 2, and this is going to be the 2019 start with the video 3. As you could see, the 12th April shift 1 and shift 2 papers. These 2 papers had quite a bit number of extra syllabus questions that were asked, and also slightly challenging ones. Okay, so without much further ado, let me go ahead with the questions here. So in case you want to check out the video 1 and 2 again, please do that, because I'll be using some of the concepts taught in 1 and 2 to ease my explanations in video 3. So please, links are in the description below, or you can go to the playlist and actually go through 1 and 2 before coming back to this. So I keep saying this, the best preparation for any JEE exam, mains or advanced, in the last leg is to solve the previous papers. That's why I call it alpha and omega. That is the starting and the ending of your preparation. Okay, so let's start with the 12th April shift 2 paper. In an amplitude modulator circuit, carrier wave is given by C of t is equal to 4 sine 20,000 pi t, while modulating signal is given by M of t is equal to 2 sine 2,000 pi t. The values of modulation index and lower sideband frequency are. Okay, so AM circuit has been given. Okay, so this is from communication systems topic. Want to give it a try? Have a pause here and then move ahead. So here's the solution and the explanation. So the thing is, in AM circuit, always you should realize that the AM wave that you can write on the top here, I'm doing it. So the value of AM function of t is always given by, you take this amplitude of the carrier wave as it is, but you add the message signal completely inside it. So 2 sine 2000 pi t and all of that, along with the rest of the function. So this you multiply it with, again, outside sine of 20,000 pi t that is there. So can you see this entire thing? So you change this 4 into a function. That's why, that means you're modulating or changing the amplitude. So that's why it's called amplitude modulation. This is simple trigonometry, right? I think any simple 10th class student would say, okay, I'll multiply with 4 sine something, and then is a product of 2 sine functions. Product of 2 sine functions can be further written as the sum or difference of 2 sinusoidal functions. So this is 3 frequency function. Since this is FM, which is the modulating signal or message signal, and this is FC, there will be always 3 frequencies associated with this. First product gives you FC, and the second product gives you FC plus FM and FC minus FM. That's why at the bottom of the page you could see, always you remember, these are also asked in other exams, the AM wave has 3 frequencies always, which is FC minus FM, called as lower sideband, FC, the middle one, and the upper sideband USB is FC plus FM, 3 frequencies. Keep track of that. Not only that, when you take this 4 out, you'll end up getting a 2 divided by 4 ratio, which in general is the ratio of the amplitude of the message signal or modulating signal and the carrier amplitude. So that's nothing but the modulation index, something that you need to remember. They keep asking this. So answer for that part is 0.5. And also simple conversions from omega C to FC, students generally forget this is actually omega, whereas all of these in hertz. So you have to divide by 2 pi, get FC value, get FM value. As I already told you, the lower sideband frequency is FC minus FM. Okay. One more important question that they ask in this kind of frequencies is the frequency bandwidth. Bandwidth is always for a spectrum the highest frequency minus lowest frequency, which in that case would be 2 FM. Okay, so that is, if someone asks central frequency, it is FC, bandwidth is 2 FM, and the 3 frequencies are as shown on the board. Okay, so something that you need to remember. So for this particular question, the answer is simply 0.5 and 9 kilohertz. Let's move on. Zener diode makes appearance again, right? So DC voltage regulator circuit, Zener is used as a voltage regulator circuit. Breakdown voltage is 6 volt. And if the unregulated input voltage, which is applied across this, is 10 volt to 16 volt, then what is the maximum Zener current? He's asking. What is the maximum value of this thing? Okay, want to give it a try? Just pause. I'm moving on. So the thing is, I borrowed that picture. Unregulated voltage supply means fluctuating. Okay. So the thing is, if you have this voltage supply directly applied across a load, then the load will get damaged. Load always wants a constant voltage. So what you do, you apply a Zener in series with this particular fluctuating voltage, and Zener always works in reverse biased breakdown condition. So it will eat away only a part of this at a constant value, and that constant would be fed across the load. In this problem, he said that constant reverse breakdown is 6 volts. So 6 volt would be not only across this, but also across this. Simple Kirchhoff's law, if the entire thing is 10 to 16 and this is 6, this part would be a variable, which would be 10 minus 6 a 4 and higher value is 16 minus 6 a 10. Okay, right? So the value of current in the load is decided by the voltage across it, which is 6 volt, divided by the load resistance, which is 4, so 1.5 milliampere. So load current is maintained constant because of the Zener presence. Therefore, since this is a constant, right, and this is a variable, as you could see, the variable can be calculated by 4 by 2 and 10 by 2, it's 2 to 5 milliampere you will get. So with a variable and a constant, this will be a variable. So also range of Iz, which is Is minus IL. So you have to subtract these two values. The least value comes out to be 0.5 milliampere. Highest subtraction comes out to be 3.5 milliampere, which means the Zener should be ready-made to be able to bear this entire current range. And in this problem, he asked maximum value. Therefore, the answer required would become 3.5 milliampere. Okay, right? So let's move ahead. A Carnot engine has an efficiency of 1 by 6. When the temperature of sink is reduced by 62 degrees centigrade, its efficiency is doubled. The temperatures of source and sink are respectively. Okay, right. So give it a try. Here we move on. So the thing about Carnot engine questions is they keep repeatedly asking either a refrigerator or an engine efficiency or coefficient of performance. So in case you have not gone through them, please do. There is only one page in NCERT, you have to refer to that. Okay. The efficiency is always given by 1 minus T lower divided by T higher, nothing but sink by source, which he mentioned in the problem as 1 by 6. Rearrange, you'd get a simple equation at the start. We also need to understand that these are always absolute or Kelvin temperatures. Okay, so that's the difference in this question. Everything is given in centigrade, so please beware. He also says that a second step, that if the sink temperature is reduced by 62, a degrees or Kelvin reduction is the same, then he says that the efficiency has doubled. So I just substituted. Put this fraction into this as it is, and then you will end up having the T source in Kelvin, as I quoted, convert it nicely into 99 degrees centigrade and just search for the answer. Second thing, you substitute back that source temperature in this, you'll get the sink value and convert it again. So the required answer obviously would be 99 and 37. Oh, so this is the correct answer. Okay, right. Let's move forward. A polarization question with system of 3 polarizers P1, P2, P3 is set up such that pass axis of P3 is crossed with respect to that of P1. The pass axis of P2 is inclined at 60 degrees to the pass axis of P3. When a beam of unpolarized light of intensity I0 is incident on P1, the intensity of light transmitted by the 3 polarizers is capital I. The ratio of I0 by I equals nearly. Okay, so want to give it a try? Just pause. Okay, here's the solution. So the thing about polarizers is you need to see certain important words and wordings that are given. My advice is if at all any question is 2 or more polarizers, always pictorially represent that in your scribble pad they'll give in the exam. Okay, so it won't take much time, but it'll give you a nice picture of what's happening. So one of the most important informations here at the starting line itself is what is meant by this word crossed with respect to. Always the crossed or cross product relates to a 90-degree angle. Okay, right? So he's talking about P1 and P3 being crossed with respect to each other. That means the pass axis between them is at 90 degrees to each other. Not only that, pass axis of P2 is inclined at 60. Therefore, if this is theta and this is 90 minus theta, he said P2 and P3 are at 60 degrees to each other. Okay, then this has to be 30, so that overall 90 degrees is managed. So I have written down those numbers also. One more important thing that you need to always notice is whether the incident light is polarized or unpolarized. As you could see in the question, unpolarized light is incident. We all know that unpolarized light, whenever it passes through a polarizer, irrespective of the direction of pass axis, the thumb rule is that it will go ahead with an I0 by 2, which is related to the random value of cos square theta and all that stuff. So once this I0 by 2 is a polarized light and passes through this, then the Mayless law comes into picture. So unpolarized light passing through a polarizer, output is always I0 by 2. And now this polarized light I0 by 2 is passed through P2 first and then P3. Therefore, two Mayless laws occur. One is a cos square 30, another one is cos square 60. So I0 by 2, cos square 30 for the first one, cos square 60 for the second one, makes it a 3 I0 by 32. Therefore, the required ratio he asked was 32 by 3, which is nearly 10.67. So this is a very important model of question that they keep asking. So please do revise the Mayless law. Let's move on to the next one. Yeah. EMWAVES, another favorite for the JEE mains extra syllabus topics. A plain electromagnetic wave having a frequency of 23.9 gigahertz propagates along the positive Z direction in free space. The peak value of the electric field is 60 volt per meter. Which among the following is the acceptable magnetic field component in the electromagnetic wave? He has given certain numbers and vectors. You need to choose the correct option. Okay, you want to give it a try? Right, let's move forward to the solution. I have actually done more questions on EM waves in the last two videos than anything else. That should give you a good idea of how to solve these questions. Okay, so I told you already B and E are always in phase in EM waves. Therefore, whatever is the phase function of B should be the same phase function of E. Phase function means whatever is inside the sign. He said the wave is propagating in Z direction, right? So propagation in Z direction, positive Z direction, means it should be omega t minus kz, minus kz. Immediate inspection of that, if you see all the three options or four options, only minus is there in C. So C is the only possible answer. But since I'm trying to explain, let's check the rest of the parameters also. Okay. We all know E bar should be B cross C, and I asked you to remember in the first two videos the simple direction propagation. C means the direction of propagation. So, and also you can change this cyclically because these are like IJK vectors, mutually perpendicular, right? So they need not be always IJK, but they behave like orthogonal IJKs. Okay, so you can rearrange them and write them in the cyclical order: 1, 2, 3, 3. 1, 2, and 2, 3, 1 kind of thing. So B cap, if you want, is C cap cross E cap. Okay, so using the magnitude relation, you'll end up getting 2 into 10 power minus 7, which matches. And the B cap, which is C cross E, right? C is given in the positive Z direction, K cap, and E bar is given to be in one particular direction that we didn't know. So you can say that the answer should be perpendicular to the value of K cap. So K cap can't be the answer. So it should be, as he said, acceptable. So just take I cap. Okay, right. And one very important thing is that omega is 2 pi f. If you convert, then you'll get 1.5 into 10 power 11 hertz. And K value that you are going to substitute here should be 2 pi by lambda. And the lambda, it can be found out from the frequency here. Okay, so when you do that, surprisingly, you end up getting 0.5 into 10 power 3 meter inverse, which doesn't fit here. It fits here, but it doesn't. So the actual answer that should have been printed should be this. So none of the correct answers are present. So it should be this one with a 10 power 3 actually. So there was no answer in this particular problem. Okay, right. Next one. The truth table for the circuit given in the figure is, so he has given two inputs, as you could see, A and B. Is asking for the output and the truth table. There are many ways of doing this problem. You want to give it a try? Pause here, and then we'll move ahead with the solution. Okay, so let's go. So the one of the methods that you would see in textbooks is also drawing the truth table. That means you put a 0, 0, 0, 1, 1, 0, all four combinations, and check and build the truth table. Since you can find them in textbooks, I'll try to give it a different way where I'll actually get an expression for this. It's a very easy one. Just follow this. I've redrawn this, and this is an OR gate, right? So OR is represented by a plus, Okay, right? And this A is taken again here. This is a NAND gate. That means you multiply these two and then take a complement. Okay, right? So the output is A into A plus B whole complement. It's always important to remember the complement rules. When you add the two and take a complement, it's as good as if you bring the complement inside, the inside operation changes. Same thing, if you multiply and then take a component, it's as good as taking complements and adding. So this is very important. You have studied this in sets rules also. Here also it will apply in Boolean algebra, where x and y. Boolean algebra means x and y can take only values of 0 and 1, true or false. Okay, so now you have A into A plus B, therefore I bring the complement inside, it becomes complement and complement, in between they'll get a plus. I'll apply again that complement rule here, it will become A complement into B complement. I take A complement common, then it will become 1 plus something. What does 1 mean? Always true. So when you have a statement and you put a OR with another true statement, answer is always true. Therefore 1 plus B prime in Boolean algebra is always 1. Therefore this entire set becomes only A prime. So with all of this drama, the answer here is just a knot of A. So you have to search for that truth table where whatever A's result, A's input is there, answer should be exact complement of that. And if you keep searching, I think you will find it here. You could see zeros here became ones and ones became zeros. So the correct answer, an alternative method that I've written without drawing the truth table, is D. Okay. Let's move forward. We have a transfer characteristic curve of a transistor having input and output resistance of 100 ohm and 100 kilo ohm respectively. The voltage and power gain are respectively. So he's given IC by IB. IC by IB is called transfer characteristic of a transistor. Okay, so want to give it a try? I'll just pause. Let's move forward. There are certain things that you need to know about the transistor, which is there in our syllabus. Among all the possible modes, we only study common emitter mode. And in the common emitter mode, the output is the collector and the input is the base. Okay, right? And current gain beta, the symbol, is of two types. One is the AC beta and one is the DC beta. If nothing is mentioned, it's always the AC beta that we always take, which is delta IC divided by delta IB. Okay, in this problem, the delta IC and delta IB can be easily found from your mathematics of the slope, right? So y2 minus y1 by x2 minus x1. So you should be very careful. I have seen students make a mistake of taking x for y and y for x. So it should be really very careful there. Voltage gain is simply given by the value of beta into R out by Rn. Okay, so all these proofs and everything, you want to have a quick revision, I would suggest you go through HC Verma, which gives to the point explanation for all of these things. Okay, right? So but NCERT is much more elaborate, but I don't think you have time in the last 1 week at least. So this is a very important formula that you should know by heart. Okay, so beta into R out divided by Rn. Beta value I already said, every difference of 5 micro ampere is greeted by a difference of 100 milliampere. Please note the units on the axis. Okay, so 5 micro divided by 100 milli you'll get here. R out and Rn ratio is 100k and 100 ohms. So I have written that. So all those cancellations give you a voltage gain of 5 into 10 power 4, and power gain is AP equal to beta, again beta times of AB. So if you want to actually write in terms of this number would be beta square into R out by Rn. So when you do that calculation, substitute that voltage gain, you again get this number. So the answer should be suitably 5 into 10 power 4 and 2.5 into 10 power 6. So we are into 12th April 2019, shift 1 now. So a magnetic compass needle oscillates 30 times per minute at a place where the dip is 45 degrees and 40 times per minute where the dip is 30 degrees. If B1 and B2 are respectively the total magnetic field due to Earth at two places, then the ratio of B1 by B2 is again best given by, so approximate answer he's asking. Okay, want to give it a try? Just pause and then move forward. So here's the solution. So the thing you need to know about magnetic compass needle, I think you might have used it before also. Whenever you hold it in your hand to check north south, you always hold it in a horizontal plane. So even if it oscillates, oscillations are all in horizontal planes. That's point number 1. Point number 2, dip is always measured in vertical plane using an instrument called dip circle actually. So these two, how are they related? Come to the vertical plane, and in any vertical plane at a place, magnetic field actually dips down. That's why this angle is called dip. So this direction is horizontal and this direction is the vertical. So if the B net, oh, there was a small disconnect from the previous video. So we'll continue this as the part 2 of the video 3. And let me go to the place where we stopped. Yeah, so we were here. So let me continue. So I was talking about the B in the vertical plane. So the dip angle is, let's say, delta. Then the B cos delta is going to give us the horizontal magnetic field, which is useful in the time period of small oscillation calculation. So 2 pi root I by m BH is the value of the time period, where I is the moment of inertia, m is the magnetic dipole moment of the magnetic compass needle. So because he has given the ratio of BH1 by BH2 here, which would be inverse ratio of the square of the time periods, and then BH can be substituted for B in terms of cos deltas, and inverse of these can be written in terms of frequencies, because he has given frequencies actually 30 times per minute. You can understand that this 30 is the frequency there. So with appropriate manipulations, you would end up having the required B1 by B2 ratio as somewhere around 0.69, a slightly difficult calculation, but I think in the exam you should be able to make out from the options how close they are. So the required answer comes out to be D. Okay, right? Then the next question is on the electromagnetic waves. It's represented in this problem with an E naught into n cap sine of omega t plus 6y minus 8z, and taking unit vectors in x, y, z directions to be I cap, j cap, and k cap, is asking us the direction of propagation this time. Okay, so you want to have a try, just pause and then move ahead. Okay, so here's the solution for that. By now you should realize that the electromagnetic waves, whatever is written inside this sine function, it's called phase. Okay, right? So, and wavefronts are always represented by the constant value of the phase with which they travel in the medium. Okay, so phi equal to constant represents the shape of wavefronts by definition. The definition of the direction of propagation is always normal to this wavefront. So whatever direction that he's talking about, it should be taken always normal to this wavefront. So this normal direction is always given by the gradient. Okay, so also it points in the direction of reducing phase. So just like your electric field lines in uniform potential maps point from higher potential to lower potential, in the map of wavefronts, the direction of propagation always points from the higher phase to lower phase. So, and is given by the gradient. There also, if you remember, the gradient of potential gives you the field with a minus sign. So using the same logic, the escape direction is always parallel to negative of the gradient of this phi. Okay, right? So gradient is a space gradient, and you would be having dou by dou x I cap, dou by dou y z j cap, and dou by dou z k cap. So as a thumb rule, just remember whatever is given inside, you take a partial derivative with respect to x, y, and z, and add I cap and j cap and k cap, you'll get the propagation vector. As you could see, here it would be 6j cap minus 8k cap, and don't forget the minus sign as I told you. So which gives you the unit vector in that direction as this number if you took the minus sign correctly. So the required answer would be the first one. Let's move forward. The numerical aperture of an objective lens of a microscope is 1.25, and if the light of wavelength 5000 angstroms is used, the minimum separation between 2 points to be seen as distinct will be. Okay, so this is a problem on resolving power of microscope. You want to give it a try, have a pause, and then move ahead. Okay, so here's the solution. So thing is, what is meant by numerical aperture is something that you need to understand in order to remember that formula. So just mugging up will not help. So when you, even though the question is on microscope, I would like to throw some light on telescope relation. So resolving power in a telescope is measured as 1 by the smallest angle between the resolvable points. Okay, so 1 by angle is the idea there. So where it is coming out to be using all the description of Fraunhofer ideas and of a circular aperture, you get A divided by 1.22 lambda. I will illustrated the same thing in the video number 2 also. So A divided by 1.22 lambda, where A is the diameter of the aperture. If you refer to the NCERT section 10.6.3, all of this resolving powers of both telescope and microscope will be very clear. But be careful, in NCERT they use 2a here because a in NCERT is considered to be the radius. So the answer is the same, but just the parameters you should be very careful about. And when you do that to that microscope calculations, in microscope you should realize the resolving power is measured as 1 by distance. It's obvious because telescope you don't worry about the distance, you worry about the angle as you are watching very far away objects, whereas in microscope you watch microorganisms which are very close by to your eye and maybe on the slide of that particular bacterial observation, and then you'll end up having the D minimum. So the units of resolving power of microscope and telescope won't match. Okay, so when you do that 1 by D minimum in that section, you go through the entire proof, you will end up getting some number divided by 1.22 lambda. Then in order to remember the formulae, they compare these two formulae and say whatever the duty of the aperture is being done in the numerator here, there is a number doing the same duty here. Okay, so here the aperture diameter or the radius is replaced by a pure number here. Okay, and what's the importance of this number? If you draw that microscope diagram under the minimum distance condition, imagine very close here, there are 2 points whose distance is D minimum, then those 2 points nearly subtend a half angle of beta with the objective of microscope. This half angle is written in that formula. Whereas mu is the refractive index of the oil with which this entire tube of the microscope is filled. So this mu sine beta, which does the duty of an aperture diameter in here, is called numerical aperture. You could see in the name also, it's like an aperture, but it's a number. Okay, so that's the story behind calling it numerical aperture. Okay, so when you rearrange this and notice that mu sine beta is Na, Na is the symbol I use for numerical aperture, and rearrange, you get 0.61 lambda divided by Na. In this problem, he has given everything. Numerical aperture is a number, 1.25 you substitute here, lambda you substitute here, you end up getting 0.24 micrometer. Okay, so that's the correct answer there. Okay, right. So I hope you enjoyed this video. Sorry for the interruption in between. There was a internet connection issue here. So let's hope it's not there in video number 4, which would be even more interesting. And it would cover the exams that are written on the screen. As you could see, the 10th April to shift 2 and 10th April shift 1 and 9th April shift 2 extra syllabus questions from 2019. One of the most challenging papers I could say. So I hope you like the videos, and you want to go ahead with the other important series that are running parallelly. Please do make sure you utilize your time in this particular aspect, especially if you are writing your JEE exams next year. This would be worthwhile your time. Okay, so in case you like this video, please do share it with a lot of your friends who are under a lot of stress in the last 1 week. It would be really helpful for them and also for my channel in order to make it grow. And your response will decide whether I'll be coming up with more videos or not. So I hope you'll be staying with me. I like your company, and I hope it is the same way with you. See you in the next video.